Now, you mentioned something there that I have to go back to because I believe this is probably part of the myths, and I'd like you to expunge on it, what other myths there are. But mycotoxins are necessary, and they're not the only thing you should be caring about, right? That's kind of what you said. So go into that, because that's going to blow some people's minds. Of what the hell are you talking about, man? Like, it's all about the mycotoxins. That's all you test for.
Yep. I just gave a talk at the biohacking conference, Dave Asprey's biohacking conference. And the title of it was More Than Mycotoxins. Okay. And so, I unpacked that for about an hour. So I'll do a very short version of that. But, when mold is growing, it produces three things. This is a hypersimplification. It produces a lot of things. But in essence, you've got spores, which are the reproductive seeds, and these are typically airborne when they're disturbed, and they can cause upper respiratory irritation, allergic reactions, these kinds of things. They also happen to carry with them, the spores themselves, some degree of mycotoxins if it's a toxin-producing mold. But spores by themselves are a natural, normal part of our environment, and you're breathing them in every day. And so the spores are not to be feared. In fact, by the way, fun fact, the kingdom fungi produces 50 megatons of spores every year. 50 megatons is the equivalent of 500,000 blue whales. And that's every year. So mold, part of kingdom fungi, is the largest producer of biological particulate on the planet. And so you're not going to get away from that. 30% of the Earth's biomass is fungi. And so we live on a fungal planet. Make no mistake. We are the guests here, not the other way around. And mold and fungi are the reason that everything works, quite frankly. And so we need to embrace them, embrace these critters instead of reject them. And so spores, and then you've got spores, you've got the microbial gases, the musty odor, what are known as microbial volatile organic compounds, MVOCs for short. Most people listening to the show are probably familiar with VOCs. These are generally regarded as man-made chemicals. But formaldehyde is a common one, but the most popular one is alcohol. And many people like that for lots of different reasons. And so that's a very popular VOC. And it's also a microbial VOC because, in fact, alcohol is made through the fermentation of microbes. And then you've also got mycotoxins, and mycotoxins are the poisons that fungi use to fight with each other and other microbes. It is chemical warfare on a microscopic level. We get caught in the crosshairs, and because we are genetically more closely related to fungi than we are bacteria. We end up, we're kind of on the winning side of that for the most part. So anyway, and by the way, the most common mycotoxins that most people are familiar with is penicillin. And so this is a semantic discussion in many ways. How do you define a chemical by its use? So if it's a mycotoxin, it kills the things you don't want. And if it's an antibiotic, it kills the things you do want. Same chemical. And so how you classify that is more a matter of personal preference or the target that you're looking for. So the bottom line is what's been happening with mycotoxins is that people focus on the mycotoxins, but the evidence is very clear that most mycotoxin exposure does not come from air. And I can tell you how I know that, because when Alexander Fleming discovered mycotoxins, penicillin, when he discovered antibiotics, penicillium. A spore had landed when he went out to lunch. He forgot to put the cover on the dish. He was cultivating streptococcus, strep throat, right? So he had a bacterial culture, and he left. And he was a notoriously sloppy scientist, so he left without the cover on top of the dish. He came back, and he saw that there was a colony in the middle of the dish that had a little clear moat around it, and that clear moat was what he referred to as mold juice. That was his highly scientific, very technical, and he literally called it mold juice. And that mold juice was clearly keeping the bacteria at bay, killing it, but also keeping it at bay. Now, if there's a misconception that if you've got mycotoxins in your house, in the dust in the corner of your living room, that it's radioactive, that it's going to get to you. But the stuff has to become airborne, and it doesn't become airborne by its own, because in fact these mycotoxins they ooze. They're more like an oily substance, and so they do collect on the outside of dust and spores, which is to say the same thing in some ways, because they all kind of hang out together. And if that becomes airborne, you can get about the amount of exposure that you would if it were on the outside of one of those cells or one of those particulates. But they're not flying around by themselves. And I can tell you how I know that's true, because if you look at the dish that Alexander Fleming had, if they were flying around, the whole dish would be clear. Instead, they ooze out because mold cares about one thing: competition on the surface it's growing on. Mold doesn't eat air. It eats the sheetrock or the paper on your sheetrock. It eats the dust that's on the surface of whatever it's growing on. And so it releases this substance which stays on the surface to provide a competitive advantage. It is not designed to be airborne. This is a factual. This is a grand misperception in the healthcare field, especially in the functional field. Honestly, where if you've got mycotoxins, or if you got a mycotoxigenic species, go forget about it. Leave with the shirts on your back. This is a dangerous philosophy, and it's an inaccurate one. It's scientifically invalid. But the thing that's interesting is the thing that's probably the underlying cause of most mold-related illness is the thing that is the most ubiquitous. See, only mycotoxigenic species produce mycotoxins, and only they produce them intermittently. So they only produce them generally when they're threatened, or when they're they're threatened by competition, or threatened by drying out. So lots of times they'll produce them quickly when they're starting to sort of like die off, becoming dormant. And so it's not a reliable way. It's kind of like the tiger versus the tail. The mycotoxins are like the tail. You want to know the tiger. The tiger's dampness. Okay. That's the enemy. Now, what happens when mold grows? The spore detects this combination lock, the right temperature, the nutrition that it's looking for, or the food source, the right, the oxygen has to be present, because these are aerobic, by the way. This is how you know they don't grow in your gut. Most of these are aerobic. So they're not anaerobic. They cannot colonize inside your gut, 99% of these microbes. And so when that combination lock, that combination kicks in, boom, that spore will then, like a seed, will release a hyphae, which is like a feeler, and it will release enzymes. This brilliant little single-celled organism will release enzymes based upon this catalog of enzymes that it has to eat exactly what it wants. And while it does that, it digests outside of the cell. We digest inside and produce gases, flatulence, and all that, which, by the way, are microbial gases. And they're not human gases. Those are microbial gases. Those are microbial VOCs. Yep. And they do it on the outside. And so it extracts the nutrition it wants, and then it releases mold burps. And that mold burp, if you will, is the musty smell. And that musty smell is a potpourri of industrial solvents, for lack of, really, truly, if you look at them chemically, it's benzene is commonly found coming off of actively growing mold. This is a group 1 carcinogen, right? Alcohols, ketones, aldehydes. It's really, truly, the industrial solvents, and these become airborne. This is where you'll see commonly with mold sufferers, that they also tend to be chemically sensitive. Oftentimes they'll become chemically sensitive. Why? Well, that's why, because the body picks up that chemical. It's a predictive mechanism, right? I smell that. Oh, bad news. Shut down, fight or flight. The whole inflammation cycle, that whole cascade kicks in because of a smell they picked up at the grocery store. But it's actually because of the chronic exposure to the musty smell in a building that they spent too much time in.